for this problem, we are going to use the product rule because we have the product of two functions. I like to think of the first function as x cubed and the second function as quantity x squared minus 8 to the 1/2 power, or the square root. So the product rule says that we're going to take the first function, which is x cubed, times the derivative of the second function. Now, the derivative of the second function requires you to use the power rule followed by the chain rule, because the expression being raised to a power is actually a function of x. So to apply the power rule, we'll bring the 1/2 down front. Reduce the exponent by 1. And then multiply by, excuse me, the derivative of the inside function, which is 2x. So there's the first part of applying the product rule. Now we have to take the second function, which is x squared minus 8 to the 1/2 power, times the derivative of the first function. But the derivative of x cubed is 3x squared by the power rule. So there's a possible answer, but we would not normally leave it like that. We'd try to simplify it. So I can see that these 2's cancel out. And I've got x to the 4th remaining in the numerator. And this x squared minus 8 to the minus 1/2 I can rewrite as, in the denominator, the square root of x squared minus 8. And for the second term, well, 3x squared times the square root of x squared minus 8. That too is an acceptable answer, but normally we would combine these two fractions into one. So we would have to multiply, we need a common denominator. We would multiply top and bottom by the square root of x squared minus 8. So that we had a common denominator. And I'll work out to the right this time. So the first fraction is x to the 4th in the numerator. The second fraction will be 3x squared. And when I multiply radical x squared minus 8 times itself, I just get what's under the radical, under the square root symbol. And all over the common denominator, which is the square root of x squared minus 8. And finally, I can distribute the 3x squared times each term in the numerator. I'll get 3x to the 4th, plus this 1x to the 4th is 4x to the 4th. And 3x squared times the minus 8 is negative 24x squared. All over the square root of x squared minus 8. And technically, you might consider rationalizing that denominator, but there's nothing wrong with that answer either. Now I'm going to share my screen for just a quick second. Go to Desmos, graphing calculator, and show you how you could have checked your work here. I've typed in the function f of x equals x cubed times the square root of x squared minus 8. Then I use the function set up here under miscellaneous to get g of x equals the derivative with respect to x of f of x. And if I unhighlight the green, there's the graph of that derivative. And then I typed in k of x as the answer that we got on the whiteboard. And we can see it looks the same way. And I inserted a table here and put in some values for x sub 1 and change the column headings to g of x sub 1 and k of x sub 1 and see that both of these give me the same set of answers for a random sample. Obviously, you cannot put a number in here that is less than 8 in absolute value because we'd be taking the square root of a negative number. So that's why that's undefined. Okay, so there's a way to check your work for a complicated problem on Desmos. I'm going to stop sharing. I'll include the link to the Desmos graph in the final answer.